Alright, finding limits analytically of sine and cosine. This is just part B. All we're doing here, we're using all the same rules as the last one, but we just have a little bit more interesting functions. So let's go to the next page because we've already reviewed all of this on the last video. Okay, so we got some interesting problems here. Not that bad though. We got the limit as x approaches 0 of 4x over tangent x. Basically what we want to do is we want to break this down so it looks like something that we know how to take the limit of. It's the easiest way to do it. So I discussed in the last video that this 4 here, we could actually rewrite this whole thing. And I would recommend just kind of thinking of it in these terms. You may not actually have to write it all out like this, but I think it definitely helps. This is the same thing as 4 times x. And since x is actually be divided by tangent, well, we can replace the tangent with sine of x over cosine of x. Okay, well, maybe it would help if you thought about this as x over 1, and then you could, I said before, this 4 here, since there's no x involved in just this 4, it's just a coefficient. We'll learn about this in a later video, but this is called one of the properties of limits. I can actually just move it out in front. So coefficients that don't have a variable in it can just be moved out in front. So I could actually write this as 4, the limit as x approaches 0. And now I'm going to write this as x over 1 times the reciprocal, which is cosine x over sine x. And then I'm going to clean it up a little bit so it looks like something that I know. So this is like saying 4 times the limit as x approaches 0 of x over sine x, I'm going to use brackets here, times cosine x. Okay, now something else we can do is that we can actually evaluate these limits separately. This is also a property of limits thing, but really, if you think about it, we already know what the limit of this thing is as it approaches 0. We have it right here. Remember, the reciprocals are the same. So this is just 1. So we really have 4 times, I'll leave the brackets there so you can see where everything comes from, 1 times, can we evaluate cosine of 0? Well, sure we can. It's easy. The cosine of 0, according to your unit circle, is just 1. And so really you just have 4 times 1 times 1, which is 4. Now, students often ask me, well, can I just create a rule, you know, whenever I see a 4x over tangent x, that it's just going to be 4? Yeah, I mean, you're going to see patterns here, and patterns in mathematics is what allow us to do like kind of quick little shortcuts. But I would recommend practicing these skills of expanding out the function and simplifying it down, because this is the kind of stuff that you want to be able to articulate well on tests, especially like the AP test. So I wouldn't try and just skip it just yet. Okay, let's do the next one. Well, the first thing I'm going to ask is there any reason why I can't just evaluate this? I don't need to look for one of these fancy ways of writing these functions if I can just evaluate it. So let's just see. If I plug in a pi for x, I would get pi times the cosine of pi. Well, again, the cosine of pi, just for you guys that don't remember, right? So this is 0, this is pi halves, this is pi. Cosine is the x-coordinate in the unit circle, so this point back here is -1, 0. The x-coordinate is -1, so that's just -1. So if I simplify this, this is just pi times -1, or negative pi. Boom. All there is to it. Let's go to the next page. Okay, so this first one actually looks really similar to this rule that we learned. And so there's not really much we have to do with this. We can see that everything's the same except for the 3 and the 4. Those are just the coefficients. It's like the a and the b here. The limit as x approaches 0, so this is just 3/4. That's all there is to it. Let's go to the next one. Okay, the limit of 3 cosine x. Again, I would recommend just seeing if you could plug this in. I don't see any reason why you can't just plug in pi fourths. If you know your unit circle, you actually should be able to do that really quickly. So hopefully you're seeing this unit circle thing comes in quite handy. So remember, this is 0, this is pi halves. This is pi fourths. And at pi fourths, the coordinate is rad 2 over 2, comma rad 2 over 2. They're the same. So this is actually pretty easy to evaluate. This is just 3 times square root 2 over 2, which is simplified as just that. Boom. All there is to it. So, yeah, you got to know your unit circle, but other than that, this is pretty easy. Okay, this one's a little bit more interesting, right? We got the tangent 7x over sine 5x. Well, let's just expand it. What does this actually equal? Remember, the tangent is sine over cosine. And if I'm dividing this whole thing by sine 5x, I'm going to write that as sine 5x over 1. And I should keep my limit notation in here. I forgot. Okay, well, let's flip and multiply. So I really have the limit as x approaches 0 of sine 7x over cosine 7x times the reciprocal of 1 over sine 5x. Now I can rearrange this because cosine times sine is the same thing as sine times cosine. So I can write this as the limit as x approaches 0 sine 7x over sine 5x times 1 over cosine 7x. Alright, now we know what this is. We have a rule for this. These are the same except for the 7 and the 5. So when we evaluate, this is just 7/5 times 1 over the cosine of 7 times x. Well, x is approaching 0. So what's 7 times 0? Well, it's just 0. And the cosine of 0 is 1. So this is just 1. And 7/5 times 1 over 1 is just 7/5. So, there we go. Okay, we got one last one here. And I would very much encourage you to try it on your own. See if you could figure out what you think the answer is. So I would pause it and then check, but I'm going to go ahead and start doing it. So here we go. One of our properties of limits, well, first of all, let me just say there's a couple different ways we can do this. Probably the easiest way to explain this is, what does square mean? It means sine 7x times sine 7x, right? That's what a square is. And so down here, I also have sine 11x times sine 11x. Well, oh, don't forget my limit. Well, as we've been doing before, when I have two parts here, I can just evaluate these things separately and then multiply them together. So this first one I know a rule for. It's 7 over 11. So I can just write this as 7 over 11. And the second one's the same thing, times 7 over 11. Well, this just equals 49 over 121, and then I'm done. Notice the limit notation goes away as soon as you evaluate the limits. Now, this leads way to another video, which is talking about one of our properties. And when there's actually a powers property. And so we could actually rewrite this like so. Since everything's being squared, I can write this as sine 7x over sine 11x, and then put the square on the outside. We're allowed to do that with limits. When we do that, we can quickly see, hey, this is just one of our rules, so this is just 7 over 11, and the whole thing is squared, and what do you know? We get 49 over 121. So we get the same thing, right? So my point is just to show you that power rule works there as well. You'll learn more about that on the next video. All right, see you guys next time.